Topic 4.3 today, trig ratios. Here we have coordinates in terms of our primary trig ratios. First of all, we're going to write down there's x, there's y, and there's 1. And we're going to say the point xy can be written as the cosine of our angle is going to be the adjacent over the hypotenuse, which is x over 1, or x. And the sine of our angle is going to be y over 1, which is y, the opposite over hypotenuse. Also, we're going to say that the tangent is going to be y over x, which is sine over cosine, or opposite over adjacent. There's also going to be reciprocal trig ratios, and those are going to be 1 over sine, and that's called cosecant, 1 over cosine, which is secant, and 1 over tangent, which is cotangent. So what we're going to do here in example 1 is determine the trig ratios for angles on the unit circle. And the point A is at -3/5 and -4/5. Now what we want to do is to draw a model and determine the value of our 6 trig ratios. Here we have -3/5, -4/5. Well, what do we know? We know that the sine of our angle is going to be the y value, which is -4/5. We know the cosine of our angle is going to be our x value, which is -3/5. And we know the tangent of our angle is going to be y over x, which is going to be -4/5 over -3/5, meaning that we got to multiply by the reciprocal. The 5's are going to cancel. The two negatives are going to multiply together to give you positive, and you're going to get 4/3. For the other three, we're going to get the cosecant is 1 over sine, which is the reciprocal of sine, so that'll be -5/4. The cosecant of the secant, is going to be 1 over cosine. That's going to be -5/3. And cotangent is going to be the inverse of tan, which is going to be 3/4. The exact values of trig ratios you're going to see on our circle here. For 30 degrees, for 60 degrees, for 90 degrees, and 45 degrees. Those are the values that you're going to see. They're going to be in positive and they're going to be in negative as you go around our circle. In example 2, let's look at the exact values for trig ratios. Determine the exact value of cosine of pi over 6, 5 pi over 6. Well, we know that 5 pi over 6 is in quadrant 2. There it is. Therefore, 5 pi over 6 is going to be, from our unit circle, -√3/2 and 1/2. Our reference angle is going to be pi over 2 minus 5 pi over 6, which is pi over 6. The cosine of 5 pi over 6 is -√3/2. In B, we have the sine of -4 pi over 3. If we drew that, you will see, going backwards, that means we have a reference angle of 1 pi over 3. And our angle is got to have the coordinates -1/2 √3/2. The sine of -4 pi over 3 is our y coordinate, which is √3/2. In C, the secant of 350 degrees would be in quadrant 4. 315 degrees is in quadrant 4. That gives us a reference angle of 45 degrees. That means that we will have the secant of 315, which is 1 over the cosine of 315. That will be √2/1. The inverse of cos is going to be secant. And that'll be √2. And for D, the cotangent of 270 is 1 over the tangent of 270, which is going to be right on our axis. That means that y is going to have a value of -1, x is going to have a value of 0 at that point. Cotangent is going to be the inverse, which instead of 1 over 0 is going to be 0 over -1, which is a value of 0. Approximate values of trig ratios. Got to make sure in this case that you're in the right degree mode or in radian mode. Let's look at example 3. Approximate values for trig ratios. Determine the approximate value, the tangent of 7 pi over 5. Use your calculator in radian mode and you're going to get 3.0777. For B, the cosine of 260 degrees in degree mode is -0.1736. For C, the sine of 4.2 in radian mode again is -0.8716. The cosecant of -70 degrees can be found by going 1 over the sine of -70 degrees. In degree mode will be -1.0642. Approximate values of angles. Well, we know that the sine of 30 degrees is 0.5. That means the sine inverse of 0.5 has to be 30 degrees. So we're going to use our calculator keys for sine inverse, cosine inverse, and tangent inverse. They're going to return one answer only. Make sure you're using reference angles to get usually two angles that are going to be there. In example 4, let's see what we're talking about. Find angles given their trig ratios. Sine of our first angle is positive 8.879 from 0 to 2 pi. Give our answers to the nearest tenth of a radian. Well, this time the sine of our angle is going to be 0.879 is approximately 1.1 radians. If I draw 1.1 radians and we draw reference angles of 1.1, those are them there. You're going to have 1.1 is one of our answers, and pi minus 1.1 is going to be the other answer, which is 2.0 to the rounded to the nearest tenth. In B, the cosine of our angle is -0.366, while cosine is negative in quadrants 2 and 3. Continuing, we're going to say that the cosine inverse is going to be 111.5 degrees, meaning that our reference angle is 180 minus 111.5, or 68.5 degrees. So therefore, our two angles are going to be 111.5 and 180 plus 68.5, or 248 degrees. Lastly, for C, tangent is positive in quadrants 1 and 2. Those are drawn there. We know that the tangent of 60 is √3. So there's our 60 degrees, and it's going to be in our reference angle. So that means it's going to be 60 degrees, and for our domain that goes from -180 to +180, -120 degrees. For D, secant's going to be positive in quadrants 1 and 4. So there's two answers again we're looking at. Well, over 8 quadrants though, there's going to be 2 positive and 2 negative answers. So the cosine of pi over 6 is √3 over 2. So that means the secant is going to be 2 over √3. No. What's going on? Oh, yes, and that's going to give me pi over 6 and 11 pi over 6, and that means the two negative ones will be negative pi over 6 moving backwards and negative 11 pi over 6. And in example 5, calculating trig values for points not on the unit circle. If we look at the point A, -4, 3, that means the x value is -4, the y value is +3. This will give me a radius on my reference angle of 5. It's going to be the terminal arm, our angle in standard position, the exact value of each trig ratio. Well, let's look at this. First of all, sine of our angle has got to be opposite over hypotenuse. It's 3 over 5. The cosine of our angle is adjacent over hypotenuse, which is negative 4 over 5. And the tangent is opposite over adjacent, which is 3 over negative 4. Cosecant is the inverse of sine. Instead of 3 over 5, we got 5 over 3. The secant of pi has got to be negative 5 over 4. And the tangent, cotangent, is the inverse of tan, so that has to be the negative of 4 over 3. Your assignment for this section, day 1 to do page 201, numbers 1 to 8, day 2, page 202, numbers 9 to 19. Don't forget, if you get stuck, complete work solutions are available on my webpage.